Now we're going to try graphs of quadratics. We've already seen this picture before. The basic curve is called a parabola. The place where it hits the y-axis, called the y-intercept, is also the constant when it's in standard form. We have the place where it hits the x-axis, are called our solutions, or sometimes they're called the roots. And in this example, it's what? Oh, we already figured this one out. -1/2 and -3. And then vertex. The vertex is the top or the bottom of the parabola. So when it opens up like this, the vertex is the bottommost point, the absolute minimum. And if it opens up or down, then the top of the curve is going to be the vertex. That's going to be the absolute maximum. All right. If A is positive, if the leading coefficient is positive, we know it's going to make a smiley. It's going to open up. And if the A is negative, if that term, that coefficient with the quadratic term is negative, it's going to open down, a frowny. If you have a positive outlook on life, you have a smile on your face. If you got a negative outlook on life, you got a frowny. All right. The parabola is symmetrical, and so we have a line of symmetry that cuts it in half. And please see that when it cuts it in half, it goes right through the vertex. And it's a vertical line, and the equation for a vertical line is x equals a number, h. So it's the x coordinate of the vertex, h. And then we can look at the symmetry to help us figure out what h is. If I can see that it hits at 4, that's one of the solutions. I'm going to call it solution 2. And then it hits at -1. I'm going to call that solution 1. Then I can add those two numbers together. I want to find the average of those two things. So -1 plus 4 is 3, and half of 3 is 1.5. So right here, that line of symmetry will be x equals 1.5, or 3/2. All right, we're going to try one. So x squared plus 5x plus 6. First thing we do is identify a, b, and c, 1, 5, and 6. 1 times 6 gives me 6 up in the top, and then the 5 is all by itself down at the bottom. Look at my factor pairs. I got 1 and 6 and 2 and 3. When I subtract, I get 5. Add, I get 7. When I subtract, I get 1. When I add, I get 5. So I have two choices, because remember, I'm looking for this 5 down here. Since I have two 5s, I look over here, and I see, oh, it's all addition, so I know it's going to be the one that gets added, so it's going to be the 2 and the 3. So the factorization of x squared plus 5x plus 6 is x plus 2 times x plus 3. Now we can take that to help us find the points on the curve. We could just plug in numbers and plot them, but I like to be a little bit more systematic than that. So there's my constant, 6, so I know it hits the y-axis at 6. When are my factors equal to 0? Well, this one's going to be equal to 0 at -2. So I'm going to have a root there. And this one's equal to at -3. Okay, then I'm going to have a line of symmetry that's going to go through them. And that should go through at -2.5, something like that. I'll make it dash just because I can. Prefer dash. It's not really part of the graph. It's just there to help us with the graph. And now let's see. If I got a 6 that's 2.5 this way, that means I'm going to have a 6 that's 2.5 this way. So I'm going to have another point right there. And then I'm going to use this. When it's in factored form, it makes my math a little bit easier. I know that's -2.5. When I put -2.5 in here, I get -1/2. When I put -2.5 in here, I get +1/2. And +1/2 times -1/2 is -1/4. So I know I'm down here at -1/4. And now I got 5 points, and I'm going to try. But that's your basic parabola. I'm just trying to draw it in right now, and I'm doing it with a mouse, and it's not the easiest thing in the world, but you kind of get the idea. And I'm going to say that's it.